Okay, so we started the exponent rules right before the break. This is going to be page, hold on, 74. Let's go back over the two rules that we learned before the break. One of the rules was the product rule. And the other one was the power rule. Okay. So side by side, this is how different they look. Let's compare them. What's one way to be able to tell them apart? The parentheses. Now, the product rule is the first rule that we learned. What would you do when you're multiplying two different powers, two separate bases? What do you do with the exponents? Remember, all of these rules, exponent rules, apply to exponents only. So most of the math that we're doing is going to be applied to just exponents, okay? So we add those, you get x to the power of 2 plus 3, and 2 plus 3 is 5. Okay? Versus whenever we do have parentheses, what does parentheses tell you to do?
Times it by how many?
Times, to multiply, to distribute. So when you distribute the exponents, you're multiplying them. So 2 times 3 is 6. Okay, so those are the two rules that we learned before the break. Okay. Quotient rule. What does quotient mean mathematically?
I forgot. Oh, the solution to a... No, that's not it. I'm stupid. Division.
Quotient means division.
Yeah.
Division. So that's why we're seeing a bunch of fractions. Fractions mean division. Fractions represent division. Fractions are a way to represent division. Okay? So with the quotient rule, this is how it would look like on your formula chart. AM over AN. Now I'm going to extend it a little bit just so we can see what we're supposed to be doing with the coefficients. Okay, regular size numbers, those are coefficients, right? The numbers that are in front of a variable. With those, you're going to divide or simplify just like you normally would any other fraction. Okay, now what have you noticed is being done with the exponents? They're being subtracted. So you subtract. And when you subtract the exponents, is always top minus your bottom exponent. Top minus bottom. So, before the break, I told you that it makes it easier whenever you separate everything. You group all of your common variables and group all of your coefficients or your numbers. So with this very first example, we have two different groups. What is one of my groups? 6 over 2. Okay, those are my coefficients. Since these are regular size numbers, they're coefficients, you would divide or simplify like you normally would. What is 6 over 2? 3. Okay. Now, the other group that we would have is x to the 4th over x cubed. You're dividing two powers, so what do you do with the exponent? Subtract. And 4 minus 3 is? 1. You get, the result is 3x to the power of 1. Now, you do not have to write that 1 in there. They will not keep it there for the STAR test, so. You can, don't have to. All right, number 1. We're dividing two powers. What do you do with the exponent? Meaning we get 3 to the power of 5 minus 3, yes. And 5 minus 3 is? 2. 3 squared. What does 3 squared actually represent? What are we multiplying?
3 times 3.
3 times 3. Remember, this is not to be confused for 3 times 2. It's 3 times 3, and 3 times 3 is 9. Okay. Number 2, we have 2 different groups. So one of my groups is x to the 6th over x squared. You're dividing 2 powers, subtract the exponents. 6 minus 2 is?
A 4.
4. On the other side, y to the 4th over y cubed. You're dividing 2 powers, subtract the exponent. 4 minus 3 is? 1. Bring it all back for your final answer. Once you're done simplifying each individual group. All I hear is rappers. How many groups do we have over here on number 3?
4.
3 groups. The first group that we have is our k's. So k over 7, or k to the 7th over k 5th. You're dividing your powers, subtract the exponent. 7 minus 5 is?
2.
2. The second group that we have are my m's. So we have m 10th over m cubed. You subtract the exponent. So 10 minus 3.
7.
I wrote 7.
Ooh.
Okay. And the last group that we have are the p's. The p's don't have an exponent on them. What does that mean for me?
Bring it down.
Put a 1. Meaning we have p to the 1st over p to the 1st. But 1 minus 1 is 0. Anything to the power of 0, keep it as a 0, and then I'll let you know what to do with it on Friday when we get to that rule, okay? But make sure if it is a 0, put the 0 on there, because if you don't put any exponent on there, that's understood to be a 1, and it needs to be a 0, okay? Alright, with the rest of the examples, I'm going to skip a step. I'm going to skip this step where you write it again. I'm just going to go straight into subtracting. Alright, number 4. The first group is what?
12.
I'm still going to write this one. 12 over 3. 12 divided by 3 is?
4.
4. Okay. The next group are my x's. What am I subtracting with my x's?
3 and 1.
3 minus 1. In that order, top minus bottom. So 3 minus 1 is? 2. The last group is my y's. What do I subtract with the y's? 6 minus 2 in that order, and we get y to the 4th. So 4x squared, y to the 4th. Number 5. What's my first group?
33. Negative 30.
Okay. So when I simplify negative 30 over negative 3, what do I get? Positive 10.
Dang.
The next group, my x's. What do I subtract with the x's? 7 minus 4 is?
3.
Okay. The next group are the y's. What do I subtract?
12 and 3.
12 minus 3.
Yeah.
12 minus 3 is?
9.
We still have one more group. What group is that? There's only one z in the whole problem. What do I need to do with it? Do I need to subtract anything?
No.
You just bring it down to your final answer. Don't ignore it. It doesn't disappear. Make sure you don't forget it for your final answer. Okay? Questions?
Something.
Okay. What's the first group?
Negative 4 and 3.
What does negative 4 over 36 simplify to?
That's 36.
Thank you. The next group.
8, 12.
Okay. So what do we subtract?
12 minus 6.
And 12 minus 6 is?
6.
Okay. The next group? B's. What do I subtract? 8 minus 2 is?
6.
And then we go on to the
C's.
C's. What do I subtract?
9 minus 3. 6.
So negative 1/9. A to the 6th, B to the 6th, and C to the 6th. Questions?
No.
All right. Almost done. All right. So for number 7, I'm going to give you a random example with just numbers on how you solve this one before we get to the variable part, okay? How you would solve something like this in 6th grade. In 6th grade, a problem like this would look like 2/3 times 6, okay? You're multiplying a fraction times a whole number. How do you multiply a fraction times a whole number? What do you need to do? Turn the 6 into a fraction, and you turn the 6 into a fraction by putting a 1 under. Then you multiply. Which way do you multiply? Straight across or diagonally? When you're multiplying two fractions, you multiply straight across. Straight across. So 2 times 6 is 12. And then you multiply the denominators. 3 times 1 is 3. Now, fractions represent division. So when you divide 12 by 3 is 4. Okay? Before you got to algebra, that is how you would solve that problem. But now we're in algebra, we see this type of problem with variables. It's the same thing. You are multiplying a fraction times a whole number, right? So how do I change this whole number into a fraction to start off? Put a 1 under it. Then you multiply your two fractions. When you multiply two fractions, you multiply the numerators, then you multiply the denominators. You multiply straight across. So when we multiply 1 times w to the 25th, what do we get? 1 times anything is itself. Then multiply the denominators. W to the 10th times 1 is?
W to the 10th.
Okay. Now you have one single fraction, just like we've been doing all of the other examples. When you're dividing two powers, what do you do with the exponent? You subtract them. So we get W 25 minus 10. And 25 minus 10 is? 15. Got it? Now, each one of these rules is very, very simple when they are on their own. Where this type of unit gets harder is where you're starting to combine all of the rules. Now, if you look at number 8, this is a combination of two different rules. You have to take care of that numerator first before you can do anything with the denominator. What are we doing here with the numerator? What rule would we apply here?
Product.
The product rule. So you must apply the product rule first. Okay, the product rule tells us to do what? When you're multiplying two bases, what do you do with the exponent? You add them. So 3 plus 7 is? Bring down 4 to the 5th. Now you have one single fraction. What do you do with the exponents? Subtract. So 4 to the power of 10 minus 5 is 4 to the power of 5. Now, yes, you can simplify it further by putting that in the calculator, but you don't have to. Okay. Number 9. Same process, same steps, but with variables. You apply the product rule first. What do we do with the numerator? Add the exponents. So 3 plus 4 is?
7.
Bring down x squared. Now what do we do with the exponents?
Minus.
Subtract.
Yeah.
And 7 minus 2?
5.
X to the 5th. Do I have any questions?
No, no.
All right.